Okay, today's lesson we're solving exponential equations and inequations. So with this first equation, example 4 to the power of x equals 256, so we want to match the bases up so that we can say have like something to the base of 4 to the power of something, and then we will look at let it equal. So I'll show you what I mean. So you'll get used to the numbers because you start to see them a fair bit. So 256 is actually 4 to the power of 4. And then now that we have the same base, because it's the same base, you can actually say that x equals 4. So we can say therefore, and there's our answer. So if we look over here on this next example, we want to have the same base. So we can remember that you can actually get a number 1 by saying 3 to the power of 0. So now I've matched the bases. I can say that 2n minus 4 equals 0, and then just solve for this. So 2n equals positive 4 and n equals 4 over 2. So n equals 2 for that one. Okay, so that way we're going to keep on doing this. Now with this next example here, the 9, we could change the 9 to be 3 squared, and then I'll still leave the power out there. And then I know that 27 is actually 3 cubed, so I'll change that, and I'll still leave the power there. So now we use our index law where we multiply the powers out. So everything, the powers get multiplied, so that would be 6n plus 6, and this one would be 3n minus 6. So now that there's matching bases, you can therefore say that 6n plus 6 equals this one, 3n minus 6. And then we go about solving, so we'll bring the n's onto this side and the 6's onto that side. So I get 3n equals negative 12, n equals negative 12 divided by 3, n equals negative 4. And there's your answer. Okay, so over here we can do similar thing. We want the same base, so I might change the 9 to be 3 squared instead. N equals 243. Now I might expand that bracket out, so I've actually got 2x equals 243. Now our index law when we're multiplying is you add the indices, so I actually have 2x minus 1 plus 2x equals 243. So simplifying this exponential part, we've got 4x minus 1 equals 243. Now I can change 243 to a base of 3, and I know that 3 to the power of 5 is 243. So therefore I can say 4x1 minus 1 must equal 5. So 4x equals 6 and x equals 6 over 4. Simplifying that equals 3 over 2. And there's our answer. With the inequality examples or inequations, you still do the same thing. You just got to remember your inequation rules. So I'm still going to try and get it to have the same base here. So 64 is actually 4 to the power of 3, so I can write that. And then therefore we can say 2x plus 1 is greater than 3. And then we go about solving. So you move the 1 over, so it's 3 minus 1, 2x is greater than 2, and then x is, greater than 2 divided by 2. So just remember, if you are dividing or multiplying by a negative number, you have to flip the inequality. That was the rule you learned in year 10 most likely. So this other example, let's get them to match bases. And 81 is actually 3 to the power of 4. So therefore I can say 2x minus 2 is less than or equal to 4. So let's keep solving. So be 4 plus 2, so 2x less than 6, and x less than 6 divided by 2, so x less than 3, and that's the answer. Okay, with this example, what you're actually going to see is that this can become a quadratic. So, and remember when we solve quadratics, we move everything to one side of the equal sign. So I'll do that first. So I'm not moving this at the moment, but I'm going to bring this, so it'd be minus 8 times 2 to the power of x, and then it'd be plus 4, and I've let that side equal 0. Now, if you have a look at this first term here, I could change that to be, another way of writing that would be 2x to the power of 2 like that, because if you multiplied this out, you'll go back to this. So that works. So if I do that, and then I keep writing out the rest of the equation here. Okay, so now that I've done that, if you have a look, if I just said, all right, let 2 to the power of x, I'm just going to show you, let it equal another letter. So I might say h, right? So if I rewrote this equation using that, I would actually have 4h squared minus 8h plus 4 equals 0. So now you can see this is a quadratic. And how do we solve a quadratic? We factorize. So if we factorize, I could take a common factor out first. I've got h squared minus 2h plus 1 equals 0. Okay, and then you factorize this. So you use a cross method or look for a pattern. This is actually a pattern. So it's actually h minus 1 squared equals 0. So therefore we could say h equals 1. Alright, but we said h is actually 2x. So you can then say that, well, 2x must equal 1. And now when we solve this, we need a matching base, but 2 to the power of 0 equals 1, so we can write that, and therefore we can now say x equals 0. So we've solved this equation. So that's what you're going to see. So if we look over here on our next one, so 3, if I wrote 3x, and I could say that's squared, and then minus 12 times 3x plus 27 equals 0. So once again, I'll say I'll write 3x equal h. That means I would have h squared minus 12h plus 27 equals 0. So we look, it's not one of the patterns, so we could cross factorize using the cross method. So factors of 27 that are going to add to negative 12. So I might try negative 9 and negative 3, because that would give me negative 9h and negative 3h, and they add to give this number here. So I've factorized it now, so it's h minus 9, h minus 3 equals 0. So I've got h equals 9 or h equals 3. But we said h is actually 3x, so I could say 3x equals 9 or 3x equals 3. And now we're going to match up the bases. So 3x, 9 could be written as 3 squared, so therefore x equals 2. And this one we could write, it's like an assumed a 1 there, so therefore we could say x equals 1. So this one has two answers. X could equal 2 or x could equal 1. Okay, with this one, because it's already factorized and it equals 0, we can say the null factor law that 2x minus 16 equals 0 or 2x plus 4 equals 0. So then we can go about solving the same. So I could write 2 to the power of x equals 16, match the bases, that would be 2 to the power of 4. So x, therefore we could say x equals 4. And we could also look at here, so 2 to the power of x equals negative 4. But we can't match these, so therefore this is not an answer. So we only have one answer for this, and that's x equals 4. Alright, and coming over to this one looks like another one of those quadratic ones. So if I changed, I could write 4 as 2 squared like that, 2x plus 3 plus 16. Now, so if I change, I could also swap this one here around. I could actually say 2x like that. Now with this could be the same as saying negative 2x times 2, 3, because when we have indices with the same base, we add them, so we would get that. So we could write this like that, plus 16 equals 0. Now, again, we'd say, all right, let 2x, I'm just making this letter up, I just like using h, so I'm using h. So we've got h squared minus 2 to the power of 3h, because that one's h, plus 16 equals 0. So 2 to the power of 3, that's an easy one, 8h, plus 16 equals 0. So this is another perfect rule. So when I go to factorise, I can see that that's h minus 4 squared. So h must equal 4, but therefore 2x must equal 4, and I've got 2x equals 2 squared. Match the bases up, therefore x must equal 2. And there's that answer.